So this is the Continuity Engine 8.5 technical briefing. So this is going to be a little different than what we've done in the past with the team, where we kind of went over sales related stuff and did a solutions overview, all of the boring stuff, right? So from the technical perspective, now we're going to do a little bit more of a deep dive. This should prepare you, you and the team for your certification program. So this will give you at least a solid foundation of what you're kind of getting into as you move into the what we call the Neverfail, the Neverfail certified administrator course and the Neverfail certified implementation engineer course, right? Which will even go even deeper into the product, right? So this is kind of like the mid-tier. There's a solutions overview that kind of does a high level of the tech. Then there's this presentation, and then there's the low level. So by the time you're done with this, you should be pretty familiar with the technology and ready to work with our teams on your first few deployments, okay? So with that in mind, let's get started. So as we've talked about in previous presentations, Continuity Engine is a technology for continuous availability. So the way we do that is we provide three different core components of Continuity Engine, which is the clone-based architecture, which we'll talk about in a couple minutes. We have data protection built into this, so we can restore data if we need to, if there is like total corruption of your data sets. And we also have what we call the application management framework that allows us to monitor different things that are happening inside the application server itself, right? So Gartner basically said that most of the outages that you will see are based on either user or application related problems, right? So back in, when we started with our first version of Continuity Engine, the real issue was hardware, right? So hardware was terrible. You'd lose disks probably a couple times a year. And it was, but the quality of our hardware has gotten so much better in the last 20 years that now you literally could have a server running 5, 10 years without any issues. So the real objective now is to ensure that we can see those anomalies that are happening inside the application server and be able to react to them very, very quickly. So with Continuity Engine, user-related issues, application problems, and they focus in on three areas, which is the application accessibility, its performance, whether it's performing the way we expect it to, right? And the services are running properly. We monitor for all of that. Of course, we monitor the physical or virtual hardware. We look at the networking also. So if you can't get access to your application server, it's kind of a moot point, right? So we have to monitor the network to make sure we have network connectivity. The underlying operating system also could be a single point of failure. So we want to monitor core operating system functions, make sure that this application has the resources it needs in order to perform properly. And even now we're talking about cybersecurity threats, right? So things like ransomware and things like that. All of these kind of come together. These are real issues that all of our customers face every single day, whether it is a banking application or it is a medical system. We have a customer that's deploying right now in Canada that has specialized heart monitoring application for those who are suffering from COVID that are in ICU, right? So these are all applications that need to have this level of protection to be able to restore those business services very, very quickly. And this is really the value that we bring to the table with Continuity Engine. So what are our core objectives for today? So we want to kind of make sure that you understand that we can recover critical applications in seconds to minutes. That is really our value proposition. And through this application management framework, we actually can protect any application that runs on Windows. We can monitor those. So you can sell this to any organization that has a critical Windows application and needs to cluster enable it, for example, right? So with the application management framework, we're able to assign basic configurations such as, definitions of services that we need to protect, the registry keys for the applications that are changing consistently, and also their data sets, so the directories and files that we need to replicate. So this gives us a proactive approach to discovering critical faults within the application stack itself. So this gives us, we can monitor the hardware, the resources, the applications, the services, the networking. All of these things come together to provide you this continuous availability model. So these are the things that we will talk about today. So Continuity Engine is based on this continuous availability model. We have three major components of this. This is, I think, probably for most of you guys will be familiar. This was in our solutions overview. But essentially, the clone-based architecture is what we've chosen to build our cluster, if you will. And the reason why we've done a clone-based architecture is because if you build up another server with a completely different identity, different security context, different sets of data, applications installed slightly different, these can not only provide you problems during failover, but you will have security related issues, and you can have orchestration problems, and it just makes this, the whole failover process a lot more complex and a lot longer. So your RTO, your recovery time objective, gets a lot longer with this, right? With a clone-based architecture, though, we basically take a copy of your original server and we use that as your passive node, right? So you have the data set, you have the same server, you have the same identity, you have the same security context. Everything's exactly the same as you had in production. So all we have to do is basically hide it from the network. It's a warm server. It is active. The operating system is up. But then at the time of failover, we just assign the IP address to it. We make it visible on the network, the same one in a local HA. Then we just spin up the services, and in local HA, that's it. You're back in business. There isn't all the data's there, the security context is there, all of the permissions are right because it's the original server. We're synchronizing those over to the passive node. Everything just lines up. And so this gives you a better user experience. It reduces your recovery time objectives down to 30 to 90 seconds, and it takes the complexity away from the failover process. But then when you add things like continuous replication on top of this, now you have a technology that can get you to near zero RPO, right? So this is real-time replication. So as changes are actually happening on your production system, the logical IO, if you will, is then captured, packaged up, and sent over the channel to your passive node, and then written out in the same logical sequence. So this happens real time, so literally millisecond differences between the primary and secondary server. And then when you add continuous monitoring to this, now you have that intelligence layer that has threshold rule sets. You'll see this in a few minutes, that basically can trigger these types of automatic failover to your passive nodes in local HA, right? So all this is with zero distance limitations. We have customers that are failing over across the planet, literally across the planet. We have one in Saudi Arabia. They have a US operations on the East Coast of the United States. They fail over their Exchange servers, right? So this is really the idea of all of this is to keep your customers working, keep their downtime to an absolute minimum, but be able to give you the orchestration process you need to restore continuity services very, very quickly. So, and we do this with by giving you even access to these passive nodes. So they are clones, they have the same identities, but we even make that easy for you. So we can even, and we'll talk about this later in the presentation, how we can, help you to streamline your maintenance windows and get to that 5 nines, if you will, with Continuity Engine, and reduce the maintenance windows down to 30 to 90 seconds. So these are things that are really critical pieces of Continuity Engine. They add a lot of value to this technology, and they're going to add a lot of value to your customers. All right, so a little bit about the internal architecture. So you have what we call the Engine Management Service. It is a Tomcat server that kind of sits outside of the protected application server. It's just basically, it's just an HTML5 UI. It's very lightweight. It can install on a non-protected Windows server, and it's used to manage the protected application servers, right? It is a stateless application. So you don't have to worry about having to create HA for this particular application. So this is, we are moving to HTML5 in the version 9 product that will be out it is probably takes up about 100 megabytes of disk space, and it can install even on a Windows 10 desktop if you need to. So it is just our management and deployment layer, and it provides you the ability to manage these systems. Now, as we mentioned, it's stateless. So if you lose the engine management service, you can install it in 2 minutes and then just point it to these deployed Neverfail clusters, if you will, and it repopulates all of the information into the engine management service. We purposely did it that way so that we wouldn't have to create another layer of protection that that was unnecessary. So, so once you get to the endpoint, which is your protected application server, the application server has what we call the Neverfail R2 service, right? That Neverfail R2 service does 4 things. It provides you monitoring, orchestration for your failover, your data protection, which means your file filtering system and rollback module, and it also provides you with WAN acceleration. So if you're going through a DR process where your secondary is at a remote location, then it will compress and deduplicate that replication stream, reducing the amount of replication traffic. And so that module is there. It is licensed separately, so you would have to sell that additional module to get that additional level of protection, if you will. But the application management framework kind of sits on top of all this stuff. It's the orchestration. It basically says, okay, I see something happening, now I need to do something with this, right? So all of this kind of sits on top of the protected application server, and then we double it, right? So we clone that production server, and we bridge that together over this, what we call the Neverfail channel. And that heartbeat that you see between the blue and the green server, that is what ties this all together. So the green server is offline, only Continuity Engine sees it, and the R2 service runs on both of these application servers. So this is a kind of a slightly different view of that same data, but it gives you a little bit more insight to what's actually happening under the covers. So the application management framework is then, is there to kind of manage most of the tasks that are going on. But there are other things that we have underneath. So we have not only the application intelligence, which we have a set of, we have multiple plugins that give you native capability, if you will, in Continuity Engine. The application management framework gives you basic abilities to protect application services, their registry keys, and their file filters, right? So those are the rules to replicate the data over. So what we've done is the application management framework, though, can actually be extended. So you can build plugin modules for very specific applications, namely to speed the deployment process and to ensure that every single deployment is exactly the same way. And these are some of the plugins that are under application intelligence, but we have 50 of them now. So there is and it's growing almost by the month. So we're continuously adding more partners and building plugins, and they're just becoming part of our library. Now, what's nice about Continuity Engine is that once the plugin is developed, when you do an installation, it actually will discover that application that's there and automatically install the appropriate plugin for that application. So this is kind of what it looks like when it's completed. So you have the engine management service, which is the red server right here. You have a desktop client, HTML5, it connects to this. It then will connect to if it's a VMware environment, you can register a vCenter with it. So you can register that to provide you with a vCenter inventory, so you can just push out Continuity Engine onto those virtual machines, those protected application server. It also uses vCenter to do automatic cloning processes. So it'll use that, the APIs from vCenter to actually create your clone copy. Now, is that possible in all cases? No, it's not. So you also have what we call an assisted cloning process. So essentially, you go through the deployment process, and then you can just call your administrator and say, okay, it's now time to clone the server to another host and data store. So you have that option available to you. We also integrate with vCenter Converter. So there are going to be times where you're going to have a VMware environment, and you're going to have physical machines that need to you need to build a P2V cluster. So if you register a vCenter Converter, it can automatically build that for you. It'll go out and clone the physical server, create a virtual machine, stand it up as your secondary, and off you go. All right. So now that once that deployment is completed, we then deploy either physical servers, or we can do virtual machines. So we support physical to physical, physical to virtual, and virtual to virtual. So this is kind of what it looks like. All right. So this is the idea here is to get you to a place where you have a management layer, if you will, and the ability to control the deployments of these of Continuity Engine. So as mentioned, we have 3 different types of topologies. We have local HA, we have DR, and we have tertiary. So local HA essentially is a clone copy locally on the same local subnet, and we're going to go into details of what this means in a minute. But the application management framework is there to provide you application-aware failover. So those rules kick in, they're monitoring real time, and there's literally a couple hundred of them. And they're all executing periodically, looking for different things that are going on the production system. And then if something happens, that triggers those rules, and each rule has what we call a recovery action associated with it. So it could be as little as sending an alert out, or restarting a service, or it could actually be a failover process. So though the application awareness is critical to making sure your local HA happens automatically. So that's built into HA. Now, what's nice about this is that the green server, your passive node, your secondary, will automatically be revealed to the network. We will assign the same IP address, and we spin up the services. Boom, you're back in business, 30 to 90 seconds. This is storage agnostic, so we don't really care what the underlying storage is. So as long as we can see it as a local disk, we're good, right? So that would be, direct attached storage to the VM, or even a SAN volume, if you will, right? This can run on any hypervisor. So we have some integrations, some really cool integrations with VMware, but it doesn't really matter as long as it runs on a Windows server. You can deploy Continuity Engine, the virtual infrastructure that's under it. It's completely agnostic to that. So that's local HA. So DR is basically taking that secondary, that green server, putting it in a different geographical location, namely a different data center, and then we assign a different IP address at failover. And it's a push button operation. So it does the DNS update process. By the time the failover is complete in 30 to 90 seconds, boom, you're back in business. DNS has been updated. The application's working. Users can access it. With this, it's push button initiated by default, right? So DR is always push button initiated. Can it be automatic? Yes, it can be almost a hybrid of like the local HA configuration, but typically most of our customers don't like automatic failover to their DR site, right? So by default, you push a button to initiate the failover. Finally, there's tertiary, and tertiary is basically the best of both worlds. So you have that fully application-aware failover, and then a third copy that allows you to disaster recovery, right? So automatic failover locally, another copy at your DR site for disaster recovery. So let's talk a little bit about automatic cloning, automated cloning. So this is actually built in. So if you had a user that has, they have a local VMware environment, they have a single vCenter, everything's managed on a single vCenter, you can use this to actually automate the entire cloning process. So you register a vCenter with Continuity Engine. As you go through the deployment wizard, it'll ask you if you want automated or assisted cloning process. So if it's automated, it's going to use vCenter APIs at the end of the wizard to automatically create and stand up your clone. And then the actual wizard will ask you during the interview process which host and data store you want to put it on. It's pretty complete in the fact that it asks you everything and then pushes all of this to vCenter. And then vCenter actually executes all of the cloning operations for you. And it's fully orchestrated. So this is really good. It works on V2V, and even with vCenter Converter, it works P2V also. So we support both of these. You just register them. You need a service account for vCenter converter, and boom, Continuity Engine smart enough to use those and be able to build your cluster automatically. Primary deployment method would be what we call a dual configuration or a pair, right? So you have a minimum of 2 servers. That server is consisting of the production server and a passive node. The secondary is introduced as part of the deployment process. So whether it is automatic, the automatic cloning process is part of the deployment wizard, or it is the assisted process we'll talk about in a couple minutes, right? Either way, you're going to build a secondary server. It'll be an exact replica of the production server, and it only happens after you've installed Continuity Engine on your production server. So everything comes over. So when you snap a copy, Continuity Engine is already installed, but there's actually automation there that will automatically reconfigure Continuity Engine to be to be a secondary server. So architecturally, this is kind of what it looks like when you're doing a deployment. So in a local HA configuration, you have a primary server, you have a secondary server. And so you're going to build a channel in the wizard, deployment wizard, that will assign an IP address for the channel for the production server and one for the passive node. So these are on the same LAN, remember. So one's going to be, and notice that the IP addresses are on the same segment. You can also have the public assign the public IP address. By default, it will just have the same IP address for the secondary. So this is a basic configuration. It's very simple. It supports both dual NICs and single NIC configuration, and you can also separate the replication onto a completely different subnet, which is nice. So say if you had a dual NIC configuration and you wanted to offload your replication traffic to, say, a replication VLAN, if you will, that 714X network could actually be, I don't know, 176, if you will, right? So now all the replication traffic is actually going over a separate virtual network if you need to. But either way, this is a very simple networking layout. And you can use these to kind of build out and even use these slides, if you will, as you present this to your customers so they can understand exactly how this is going to be deployed. Now let's talk a little bit about DR. So DR is a little bit different in the fact that you are now on separate subnets, right? So notice that the channel IP addresses are on different subnets, one on the production side, one on the DR side. Also notice that the IP addresses for the public IP addresses are different because now you're going to a different subnet. We got to do DNS injection. Also notice that the production and DR sites have their own domain controllers in DNS. When you set up the deployment, it's going to ask you what the new IP address is during the deployment wizard. It's going to ask you what the subnet mask and the DNS server is for your secondary server, so the one at the remote location. That is the one that it will update at the time of failover. And so let's now talk about how this works, how the channel works. So with the Neverfail channel, it provides real-time data of the replication data, in either in the existing network or even a dedicated network, right? So we talked about that offloading it to like a replication VLAN. That is possible. It can run over the production network. It can run over the same subnet that your public IP address is on. But the idea here is it basically routes all of the replication and monitoring traffic over this specific set of IP addresses, so that it's closed. It's the data is only going from point to point, and it allows us to communicate with the passive node without having a public IP address on the secondary that's active. All right, so let's talk a little bit about a trio configuration. So trio is basically a modified or hybrid version of HA and DR. This model is designed for to have 2 servers located in the local data center for high availability, and then there's one at a remote location for disaster recovery. So the end result is that you have, you'll have three nodes in your cluster. The active and the passive will have the same IP address, but then you'll have a second copy or a third copy at a remote data center that will have a unique IP address. And Continuity Engine is designed so that everything is unique, right? So that everything, each node is completely isolated and separated from each other, so that when we do these failover processes, we use the Windows filtering APIs to actually, which is built into Windows, to assign the IP addresses at the time of failover. When we use the Windows APIs to do the failover process and assign the IP addresses at time of failover, it just works. It's awesome. So there's no IP address conflicts. There's no name conflicts. Notice that you have the green copy and then you have the gray copy, all of which have Neverfail installed, all of which are clones of one another, all of which have the same application. So the networking for a tertiary is a little bit different, right? So with a pair configuration and either HA or DR, it is you only need one set of IP addresses for the channel. With tertiary, you need two sets of IP addresses. So you're going to have an IP address that goes from primary to secondary, secondary to tertiary, and then tertiary to primary. So it's a mesh configuration, if you will, and all the nodes can talk to one another. But what's nice about this is that during the actual deployment wizard, you'll actually, it asks you for all of these IP addresses in the right order that you need to do them. So you can very easily understand it, and you can deploy this very, very easily. But notice too that the local HA copies are on the same subnet. They report to the same domain controller, but the tertiary has a new domain controller at the remote location so that it can do DNS update. All right, so assisted cloning. So the other thing that we provide you is the ability to run a deployment without the need of having a vCenter, right? So when you go in, you can actually if you don't have a vCenter, or maybe it's a physical server, or maybe it's a non-VMware environment, there are certain reasons why you would want to do an assisted cloning process. First of it is maybe you just can't get permissions, right? So even if it is a VMware environment, they just do not want the continuity folks touching their vCenters. The other thing is that you could have a situation where you have very large data sets that need to be seeded. So you need to do the deployment, do an export of the VM instead of actually doing an automated clone, and then you need to ship that to a remote location. Maybe it's Azure or AWS or Google Cloud Platform. Maybe you have multiple vCenters that are security isolated. So the DR site is on a different vCenter just because it is the DR site and they're completely isolated from the rest of the world. So essentially you have to ship that VM, that clone copy over, import it, and bring it into this. So that's why you would need an assisted cloning process. Let's talk about packet filtering now. So with packet filtering, this ensures that only one copy of the server is available at any one time on the network. So what we've done is we've integrated with Windows filtering platform APIs. Back in the day of, in the version 6 days, we used to have a specific packet filter VXD, if you will, that was part of the operating system we installed. We then replaced it when Windows 2008 R2 came out. They provided these new APIs. And so we wanted to use native Windows APIs to do this, and it's bulletproof. I mean, it really is stable. It provides a smooth transition between the active and the passive nodes. It just works. It works really, really well. So this kind of talks a little bit about the Windows filtering platform and why we actually use it, an architectural diagram that shows how Continuity Engine works and how it actually uses these APIs. It basically calls the base filtering engine using the Windows filtering APIs. That actually talks to the operating system. And from there, we can assign IP addresses, we can assign subnet masks, DNS servers, all of these things. All of this can be configured within the server configuration wizard. So you do not have to go to the Windows version 4 properties to configure anything with Continuity Engine. You can either do it during the time of the setup, if you will, or going through the deployment wizard, or you go through the server configuration wizard, which is actually installed on every node in the cluster. That's our product, right? So you go in there and you set up your public IP address, your channels, your management IP addresses. Everything is done through the server configuration wizard. We've also implemented Windows, and a lot of people have never heard of this before, but there's a feature in Windows called skip as source. So what is skip as source? Skip as source, allows you to basically take the reply to any IP socket, if you will, that's coming in through one of the other interfaces, and be able to say, I don't want you to reply on the same management interface. I want you to go out a different one, right? So with skip as source, basically it allows us to force all of our channel replication through the channel. It allows us to send all management IP information out management interfaces. So there, you don't get the confusion within the server. Okay, I have 3 IP addresses on the same network. I'm just going to send it out whatever next one is available, right? So this basically gives you the ability to set which interfaces you want certain types of application services to talk out of. So this increases the reliability of Continuity Engine, because we can restrict which interface that our channel talks out of. We also have the ability to fit this to most network configurations. So we either have a single or a dual NIC configuration. So we talked about this a little bit earlier. In a single NIC configuration, you can run the channel and your public IP address all on the same interface. The other thing is that some organizations want to offload their replication traffic to, say, like a replication VLAN. So you can use a dual NIC configuration to do this. This is, and you can even have it on the same network segment. It's okay. You can offload it to a different virtual LAN for that replication. If you're going to do this on a different subnet, you have to put a static route in place, just to make sure that all of the replication processes weren't running correctly over the right network. But our professional services will help you with this, right? So they tell you exactly at what step to put these the static route in place, and if you're offloading to some type of replication VLAN. But so these are the 2 different ways of implementing the networking configuration. So WAN-Smart is actually our bandwidth optimization technology that is built into Continuity Engine. It is licensed differently. So it is not automatically added, and it's only used in a DR configuration. If you have a customer that has low bandwidth or congested bandwidth, you would definitely want to have WAN-Smart as part of this deployment. We also have another technology called auto recloning. So now we're going to get into some of the patch management features of Continuity Engine. So auto recloning is a technology that is designed into this for VMware environments. So for example, if I have a virtual machine that I've just done a major application upgrade, auto recloning wizard in here will allow you to either through a manually initiated process or a scheduled process to reclone that passive node. You can even schedule it. So if you did patch Tuesday, which a lot of organizations do, on Wednesday night, you can run this auto recloning process that would push all of the patches into your passive nodes, right? So this is usually designed for VMware environments because we're using the vCenter APIs to do this. Now, does it support assisted cloning process? Yes, it does. So you can, if you need to do this on a non-VMware environment, or maybe you wanted to use this orchestration process for a physical server, you can manually do this using auto recloning. The upgrade process is pretty straightforward. This is as easy as it gets. You just run through a wizard, but essentially you go through, it asks you, it does a validation step, if you will, to make sure that the server is ready for this, the production server is ready for the upgrade process. It does a 30-second, 90-second, 30 to 90-second validation step, and then it just pushes the kit out. First to the production server, upgrades that, and then it relays the kit over the channel to your secondary server, it upgrades the secondary server through our automation process, and then it relays from the secondary to the tertiary and then updates that. So it could take a little while for all of these updates to happen, but the key thing is it's fully automated, right? So you don't have to worry about having to go to each node in the cluster and do this manually. The upgrade process is completely automatic and provides you with the ability to roll these out very quickly. And you can actually do multiple upgrades at the same time. So if you had 5 servers, you could just run the upgrade wizard on all of them, and they're just kind of all running in the background, if you will. And then there's Cozen passive node management. So this is actually a really, really cool technology that we've built in and actually implemented in Engine 8.5. So since these are clone copies of the production system, one of the challenges that our customers had is that, if I have to patch these passive nodes, I actually have to switch over the users to my technology, so such as an SCCM or a Quest case or Kaseya VSA or whatever, IBM BigFix, whatever it may be. What you're going to have to do is you're going to have to push those changes down. Why? Because this is a clone-based architecture, it already knows its configuration database says, I've already patched the server. So what Cozen does is it tricks third-party applications into thinking that these guys have unique identities, right? So create this alias, if you will, on a management IP address that's separate from the public IP address. We register that in DNS and give it a NetBIOS name. And now all these technologies now see it as a unique server, and it really isn't. It's still the same underlying namespace, but it provides you with the ability to patch these things pretty reliably. So the idea here is you have what we call a public name, which is that Cozen name that we talked about, that alias. Then you have a secondary management name, and then you also have one for the primary and then one for the tertiary, right? So you have these management names. And then you register those management names in DNS, and it creates a NetBIOS name for you. So when the server hits that IP address to update the server, it actually is presented with a different server name. So all of this is kind of used to trick third-party instrumentation to be able to see that these are unique identities. So here's kind of the steps that you go through. So you have step 1 that allows you to set up the management name, and you do this on each node in the cluster. And so you have a unique name for every node in the cluster. Then you add a management IP address, and then you tell it whether you want to register it in DNS and create a NetBIOS name. So once you do that, the idea here is that if you are in passive mode, you will be able to project this management IP address, right? Or this Cozen name, if you will, or the management name. So it only works if you're in passive mode. If you're active, then you have the primary namespace. You don't really need Cozen for that, right? You only need it to allow you to access these passive nodes. So once it's up and operational, it looks something like this. So now you have a management IP address for each one of your nodes in the cluster. You have this case in this diagram, it shows SCCM out there. Primary namespace would be kspatch.neverfail.com. What we're going to do is we're going to add a different name for each one of these nodes. So we'll have the Cozen name, which is kspatch1 for the primary, kspatch2 for the secondary. Then it also creates that in that same name, the NetBIOS name. So now we have uniqueness across all of the nodes in the cluster. So while you're patching the primary namespace, you're fine. The primary is active, it uses the primary namespace. If it is a passive node, then you use the Cozen name. So you add this Cozen name to your configuration, and it pushes all of the patches down to the passive nodes. So this works really well. We have this actually, we have this out there with multiple customers. It solves a huge need for our customers. Data rollback module. So data protection is built into Continuity Engine. You have what we call real-time replication. We've already talked about that, but we do have what we call a data rollback module. It is based on VSS, and it allows you to take periodic snapshots of your data sets. You can do it uniquely on every single node in the cluster. And so this gives you recovery points in case you get ransomware or some type of malware attack, or you just have some type of logical corruption of the protected datas that we're replicating, right? So you can roll back and get these without having to go back to your backups, right? So rollback module happens instantaneously almost. It takes I've seen it take maybe a minute or two to complete, but it's very, very quick. And then and then once it's done, it actually powers up the server again, and all the services come back online, and boom, you're back in business again. So that's the data rollback module. We also allow you to use Cozen to offload your backups. So in conjunction with Cozen passive node management, you can decrease the overhead on your production servers by offloading backups to your passive nodes. So this is this is a great solution. You can use those management IP addresses to use backup technologies, and we've certified technologies that work with Cozen. We've also certified a list of different patch management technologies. And then finally is, the idea is we want to get you to 5 nines. And that's a very big struggle with Windows servers, considering that sometimes the update processes can take hours to complete. So what we've done is we've said, okay, we'll use Cozen to allow you to patch those passive nodes offline, right? If it takes multiple reboots of those servers, it doesn't impact the end user. So your maintenance windows go down significantly because you don't really have to worry about that impacting your end users. You're patching the passive nodes first. Then what it does is that it also allows you to test those patches. Because this is a clone-based architecture, you can validate those patches, be able to prove that they work before you do it on your production server. Now, all you have to do is just switch over 30 to 90 seconds, and boom, you're back in business, right? So your users are now on the recently patched servers, and now you can take down your primary server with no impact to the users, and you can go through the whole patch cycles. If it goes on for hours, you don't really care. So we take you from hours for a maintenance window to do your patching down to literally just a couple minutes. So this is kind of the data rollback module. Essentially, you have these recovery points, if you will. You can set up which directories, that you want to have these recovery points associated with. By default, it will actually do these VSS snapshots. So that is while you're replicating the data over, you can actually create these snapshots also on the secondary and tertiary server. So then if you have some type of corruption of the data, or maybe some type of malware or ransomware, you can quickly fail over to those servers. Thank you for joining us today for the Neverfail Continuity Engine technical briefing. This does not end your training with Continuity Engine. This is only the beginning. You also have the option of taking the Neverfail Certified Administrator course and the Neverfail Certified Implementation Engineer course. These will go deeper into the subjects of how to administer Continuity Engine, and also how to design and deploy Continuity Engine. So if you have any additional questions, you can reach out to our sales team. They would be more than happy to answer any questions you have. And if you have other technical questions, they will pass them on to our technical team here at Neverfail, and we'll get back to you as soon as possible. On behalf of all of us on the Neverfail Continuity Engine team, we thank you and take care, and we'll see you soon.